Let's find this limit as x approaches 0 from the left-hand side. And we have this rational function, it's radical x squared plus 5x plus 10 minus radical 10 all over x. So the first thing we do when we plug in 0, right? I mean, that's usually what we should do first, right? We plug into 0, notice what happens. Okay, so we get radical, 0 plus 10 minus radical 10 here. And then we have just 0. Okay, now the fact that it's coming from the left side here, because the negative doesn't really matter. Okay, but notice we end up with 0 over 0, right? That's called an indeterminate form. Okay, now, as we've learned as well, right, that does not necessarily mean that the limit does not exist. Okay, whenever you see these radicals, and in this case, they're radicals in the numerator, right? So one algebraic method you always want to do is, rationalize the numerator. Okay. So what does it mean then to rationalize the numerator? Well, we're just rationalizing as we normally do, but we're just going to multiply by, in this case, this guy, right? The conjugate of the numerator. So we're going to rationalize the numerator. So we get x squared plus 5x plus 10. And now we're going to multiply by plus radical 10 here, right? That's the conjugate of the numerator, right? And we're going to multiply the denominator by the same thing. Okay, and then plus radical 10 here. Of course, if you need to put parentheses around these, right, just to, make sure you do everything carefully here, right, we can make sure you do that. Okay, so what happens when we multiply these out? Well, we know that when we multiply conjugates together, when we FOIL these, right, we only actually need to multiply the first terms together and the last terms together. And we should not end up with any radicals in the numerator, right? Notice what we end up with. We end up with x squared plus 5x plus 10. And then, okay, the outer and inner terms cancel out. But then what are the last two terms? It's minus radical 10 times radical 10, which is just minus 10. Now in the denominator, I am not going to actually distribute through, so I'll just keep this down here, right? X squared plus 5x plus 10. And then plus this next radical 10 here. Okay. Now notice what happens here, right? This turns out pretty nice, I guess we'll call it, right? 10 minus 10 cancels out. Notice in the numerator, we can actually factor out the x term there, right? So notice what we get. We get to factor out the x. We get x plus 5. And then on the denominator, you notice we still have that x down there, right? Which, well, in this problem, it turns out pretty nice because we can just cancel out these x's here. Right? This is our final answer, right? I should be writing the limit, right? So what are we left with? We are left with the limit as x approaches 0 from the left side, the negative, right, of x plus 5, all divided by radical x squared plus 5x plus 10, and then plus another radical 10. Okay? So we have successfully rationalized the numerator here. Notice what happens when you plug into 0, though. Now, once again, in this case, it doesn't matter if we're coming in from the left side or not, okay, because we don't end up with the 0 in the denominator. Okay? So notice what happens, though, right? We get 5, or 0 plus 5, which is just 5. And this is the key point here, right? Notice in the denominator, we get what? Radical 10 plus radical 10 now. So we get 5 over 2 radical 10. Okay, as a decimal number, right, this is approximately 0.79-ish, okay? But it's not a 0 in denominator, right? That's the whole point here. So we do get a number, right? So in this case, 5 over 2 radical 10, or if you just leave it at a decimal, 0.79. So this limit does exist, okay? It's going to be 0.79.